Welcome to part 2 of our Chapter 4 Test Answer Show. So on number 8, we have the arc length formula where S is the arc length, R is the radius, and theta is the measure of the degree in radians. And that's where a lot of you made an error. You just plugged in 8 for theta. So what we need to do is change 8 degrees into radians. Now, if you want the exact answer in radians, you can simplify the fraction, 8 divided by 180, and we get 2/45. So this is equal to 2 pi over 45 radians. So now we can plug this in for theta and solve for r. So 7 equals the radius times 2 pi over 45. So we'll divide both sides by 2 pi over 45. Seven divided by the quantity, 2 pi divided by 45. And we get about 50.1 inches. Okay, number 9, solve the triangle. Well, solving the triangle means finding all the missing angle measures and the missing side lengths. So first, angle A. We know that these three angles add up to 180 degrees. So we subtract the two angles we know from 180, and we get 61. So A is 61 degrees. Well, now to find A and C, the lengths of two of the sides. You could use either angle A or B to solve this problem. I'm just going to use angle B, the angle I'm given. So I'm looking for the adjacent, and I know the opposite side, so I'm going to use tangent. Because I know tangent is opposite over adjacent. So tangent of 29 degrees equals 16 over A. We can multiply both sides by A. A times the tangent of 29 degrees equals 16. Then we'll divide both sides by the tangent of 29 degrees. Now, I'm dealing with degrees, so make sure that you are in degree mode before you type in. 16 divided by the tangent of 29 degrees is about 28.9. Now, let's say that you forgot and left it in radian mode. You'd have gotten 18.03. Well, since this is 61 degrees and this is only 29, this answer is not very reasonable. Now, for the hypotenuse, if I use the 29 degree angle, I know the opposite side, and I'm looking for the hypotenuse. So I'm going to use sine. So sine of theta equals opposite over hypotenuse. So the sine of 29 degrees equals 16 divided by c. We'll multiply both sides by c. And then we'll divide both sides by the sine of 29 degrees. Okay. In degree mode, 16 divided by sine of 29. And I get about 33. Number 10, I just asked you to find the period of that trigonometric function. And for cosine, period equals 2 pi over b, where b is the coefficient of the x term. So here, b is 5 pi. So 2 pi divided by 5 pi is 2/5. Number 11, we're trying to find the horizontal and vertical shifts. Well, the vertical ones are pretty easy. It's just what's added or subtracted at the end. So the vertical shift is down 3, or you can just write -3. Now, for the horizontal, we're looking inside the input of the trig function. And a lot of you just put, oh, it's -pi. Well, if it was just x plus pi, you'd have been right. But 4x plus pi changes the problem. We actually want to rewrite this with factoring out the number in front of the x. So we'll factor out 4, which gives us x plus pi over 4. Remember, when you factor, you can find what's inside by dividing by the number on the outside. 4x divided by 4 is x. Pi divided by 4 is pi over 4. So the horizontal is going to be negative or left pi over 4 radians. Number 12. A 35-foot string is placed from the top of a flagpole to a point away from the base with the angle of elevation of 35 degrees. And that's our picture. How tall is the flagpole? We're looking for that side of the right triangle. So using the angle we know, we're looking for the opposite. We know the hypotenuse. So we'll use sine. Sine of 35 degrees is equal to x over 35. Multiply both sides by 35. X is equal to 35 times the sine of 35 degrees. Always check your mode. We're good there. 35 times the sine of 35. And we get about 20.08 feet. Okay, last page. A point located 7 inches from the center of the wheel. The wheel is rotating at 90 revolutions per minute. So every revolution, this point is traveling this circumference of the circle. So I'm going to start off with the quantity I know, 90 revolutions per minute. The circumference of a circle is 2 pi times the radius. So 2 pi times 7 inches is 14 pi inches. So one revolution is 14 pi inches. Since I'm trying to cancel out the revolutions unit, I'm going to put the 1 revolution on the bottom, and I'll put the 14 pi inches on the top. So now our answer is in inches per minute, but it wants us to put it in feet per second. So let's first go ahead and change inches to feet. We know that 12 inches is equivalent to 1 foot, so the 12 inches will go on the bottom. So remember, we're trying to cancel out the inches units, and we'll put 1 foot on the top. Now we have feet per minute. We know that 1 minute is equal to 60 seconds. 1 minute, 60 seconds, and the minutes cancel out. So we're left with feet per second. Now we just need to figure out what that quantity is. So on the top, 90 times 14 pi times 1 times 1. The ones aren't necessary, but you can do it. And on the bottom, we've got 1 times 1 times 12 times 60. And so we get about 5.50 feet per second. Okay, number 14. Point A is 10 miles east of point B. Point C is 7 miles south of point A. We want to find the bearing from point C to point A. Many of you found the distance from point B to point C, not the bearing. So the first step in finding the bearing is we're going to want to find out what this acute angle is in the triangle. So I know the opposite and adjacent, so I'm going to use tangent. So the tangent of theta is equal to 7 over 10. So I know that theta is the arctangent of 7/10. Now, since bearing uses degrees, we need to make sure that we are in degree mode. So we'll do second tangent of 7/10. And I get about 34.99 degrees. But that's not our answer. We know that with bearing, we start either the north or south direction. Notice from point B to point C, we're going south. Then we're looking for this angle measure right here, which is 90 degrees minus the 34.99, and we get 55.01. So south, 55.01 degrees east. Then our last one, simple harmonic motion, can be found either with sine or cosine. So A, or the absolute value of A, is the maximum displacement. So that's 8. The frequency is 22. Now we're not going to put 22 in for omega. We know that frequency is omega divided by 2 pi. So we'll solve for omega by plugging in 22 in for F. So multiplying both sides by 2 pi, omega is 44 pi. So we have A, we have omega. Now we just have to determine which one we're going to use. Well, I know cosine will either start above or below the axis, depending on whether A is positive or negative. And I know sine, regardless of whether A is positive or negative, will start at 0. Well, it tells us that the displacement at time equals 0 is 0, so that means we are not going to use cosine. We're going to use sine. So y equals 8 sine of omega, 44 pi, times t. That's it for the test. Good luck on Friday.